So far we have solved using factor form, and we have yesterday simplified square roots. So why are we going to simplify square roots? Take so much time to work on operations of square roots and simplifying? Because today's lesson we're going to focus on how to solve quadratic equations using the square root method. So we know that in standard form we have ax squared plus bx plus c. So when we're going to try and use square root method to solve, we want there to be no b term, so no linear term. We want the b value to be 0. So when we do this and we look at the steps on how to solve standard form using the square root method, we want to make sure that we get the ax squared term by itself. Then we just simply want to square root both sides. Now the goal is to also have my a value divided out, so it's just x squared, and we'll see these in these examples. So if I have the first problem, x squared minus 6 equals 30, I want to get the ax squared part of my equation by itself, so I'm going to do that by adding 6 to each side. When I add 6 to each side, I get x squared equals 36. Now we have to ask ourselves, how do we undo squaring a problem? And the way that we undo squaring, just like the way we undid subtraction was to add, is we undo it by taking the square root. So I'm going to take the square root of each side. Now the square root of x squared, we think about how we simplified yesterday. I have an exponent of 2, and I'm going to divide that by 2 because I'm looking for a pair. You get 1, so that leaves me with just an x on the outside. And we can think to ourselves the square root of 36 is 6. We can put that into the calculator. But the thing we have to remember about quadratics is there are going to be 2 answers. So there are actually 2 things that we can multiply together to give me 36. I can use 6 times 6, which will equal 36. Or I can use negative 6 and negative 6, because a negative times a negative is also a positive. So my 2 answers here are going to be x equals positive 6 and x equals negative 6. Now you can save yourself a little bit of an effort here and a little bit of time by writing your final answer as x equals positive and negative 6. You can totally write them out separately if you want to, but this is just a quick and easy way to make sure that you have both answers, the positive and the negative version. For number 2, we have 3x squared equals 180. So I don't want to start by taking the square root because 3 is not a perfect square, and that gives me some weird decimals to have to deal with. So I'm going to isolate the x squared before I get started. And the way I'm going to isolate it is by dividing each side by 3. So I have x squared will equal 60. Now to get rid of the x squared, I undo it by taking the square root of each side. So we have x equals. Now if we just leave it square root of 60, we're not in simplified version. We talked about yesterday, all we want to do is simplify, simplify, simplify. So I'm going to take 60, the square root of 60, and break it down using factor trees. So I'm going to use 3 and 20. I can break down 20 to be 5 and 4. And then I'll break down 4 to be 2 and 2. So if I look, I have a pair of 2's that will come out, and I'll have a 3 and a 5 that's left. So I'll have x equals 2 on the square root of 15. Remember, because we're taking the factors, anything that's left over, we multiply together. Again, I have to have 2 answers, so I need the positive and the negative version. So I could write it separately, where x equals 2 on the square root of 15 and x equals negative 2 on the square root of 15. Or I could write this as x equals positive and negative 2 on the square root of 15. It's really your preference. Just make sure you have 2 answers on each of these problems. So for number 3, I need to start this problem by subtracting 10. The goal is to isolate x squared, but remember we have to go through the proper steps. We're working PEMDAS in reverse order. So my order of operations, but in reverse. So when I do this, I have 4x squared. That will equal 36. In order to get x squared by itself, we need to divide both sides by 4. So I'll be left with x squared equals 4. To undo x squared, we need to take the square root. And I take the square root of each side. Remember, I get two answers, x equals 2 and x equals negative 2. Or you can just write it all together, x equals the positive and negative version of 2. Now, sometimes when we're solving these, we're going to end up having a negative in the radicand, or in the radical. And when this happens, we're going to say that this equation has no solutions, because when you type this into the calculator, it's going to tell you domain error. That's going to be something you deal with complex numbers in another class. So we look at number 4. To get x squared by itself, I need to divide each side by negative 8. So when I do that, I get x squared equals negative 30. Sorry, when we divide 216 by negative 8, we get negative 27. And so we still want to get rid of our x squared. We do that by taking the square root of each side. But notice that I have this negative inside of my radical, and if I were to type into the calculator the square root of negative 27, it's going to give me domain error. And when it says domain error, we know that there are no solutions. Let's quickly discuss what this would look like on a graph. For a graph to have no solutions, my a value here is negative, which means it's going to be upside down, u, concave down. So it could look like this. And remember, when we're finding the solutions, we're looking for x-intercepts. So where does that graph touch my x-axis? And it doesn't. So look at number 5. We're going to start by adding 6 to each side. When I do that, I get 5x squared equals negative 125. Divide each side by 5. We know x squared equals negative 25. I want to take the square root of each side, and because I have this negative inside of my radical, this will be no solutions. Please make sure that you are still showing your work on each of these problems. So if we continue to practice, subtract 8 from each side. Now this is a mixture of all problems, so I'll have 5x squared equals 250. And divide each side by 5. When I do that, I will have x squared equals 50. Still want to take a square root, but I have x equals positive negative square root of 50. I cannot leave it square root of 50 because it can be simplified. So I want to break this down. I'm going to say 50 is 25 times 2, and I have 25 factors into 5 and 5. So for my final answer, I'll have x is equal to the positive negative of 5 on the square root of 2. Remember, I had a 2 that was left over still at home. We're working on number 7. I'm going to add 1 to each side. So I have 3x squared equals 60. And divide each side by 3. When I do that, I'll have x squared equals 20. Again, square root each side, but I do need to factor 20. So that's going to give me 4 and 5. Factors of 4 are 2 and 2. So as I get ready to write my final answer, that x equals the positive and negative version of 2 on the square root of 5. And this is why being able to simplify radicals is so important. The last one, we start by subtracting 8 from each side. When I do so, I get 8x squared equals negative 128. Divide each side by 8. Left with x squared equals negative 16. Go take the square root of each side. I notice I have a negative inside of my radical, so this one will be no solutions. Now what happens if we go, instead of standard form, to vertex form? We're going to treat it the exact same way, except for I want to isolate the parentheses that are being squared. the binomial. So if I look at number 9, I'm going to start by adding 3 to each side. So I'll have x minus 4 squared equals 16. Now at this point I have to take the square root because I need to get rid of the squared. So I take the square root of each side. When I do that, I'm left with x minus 4 equals positive and negative 4. Now I have to solve both of these factors. This is where we have to be careful because when we do this, we have to set x minus 4 equal to positive 4 and x minus 4 equal to negative 4. People get confused often and they try and change the signs on the inside to x minus 4, x plus 4. Remember, that is not what the positive and negative are going to the answer. So then I just solve, add 4 to each side, and when I add 4, I'm left with x equals 8 is one solution, and x equals 0 is a second solution. When we look at number 10, we're going to start by dividing this problem by 2. So I have x plus 3 squared equals 20. Now I need to square root each side to get the squared away. Remember, I want to simplify the square root of 20 as much as I can. So it'll be 5 times 4, factors of 4, 2, and 2. So I'll have x plus 3 equals the positive and negative version of 2 on the square root of 5. This is also where, when we simplified radicals and we added them, that you remember you can only combine like terms. So if I have x plus 3 equals positive 2 on the square root of 5, and x plus 3 equals negative 2 on the square root of 5, when I get ready to subtract 3 from each side, I can't combine these because the 3 does not have the radicand of 5. So when I write my final answer, it is x equals 2 on the square root of 5 minus 3, and x equals negative 2 on the square root of 5 minus 3. These would be my two answers. Okay, number 11's got multi-steps. I need to start by subtracting 2 from each side, where I have 1/2 times x minus 6 squared is going to equal 8. Remember, to get rid of the 1/2, I can multiply each side by 2. That's the reciprocal. So I'll be left with x minus 6 squared equals 16. Well, I want to get rid of my squared, so I do that by taking square root. So if x minus 6 equals the positive and negative of 4. So x minus 6 equals positive 4, x minus 6 equals negative 4. Then I just want to solve for x on each of those. I'm going to add 6 each side. So I get my two answers to be x equals 10 and x equals 2. Number 12, I'm going to start by adding 12 to each side. So when I do that, I get x minus 4 squared equals 12. Well, in order to get rid of the squared, I'm going to need to take square root. Remember, I'm going to need to simplify the square root of 12. So that's factors 2 and 6. 6. And my factors of 6 are 2 and 3. I have a pair of 2s with a 3 left over. So this will leave me x minus 4 equals the positive and negative version of 2 on the square root of 3. So just like on number 10, now when I added my 3 to each side, I couldn't combine them because I didn't have a square root of 5. Same thing's going to happen here. I don't have another square root of 3, so you can tell that my answers will look like x will equal the positive and negative version of 2 on the square root of 3 plus 4, because I had to change my sign here. For number 13, I want to subtract 9 from each side. So I'll have x minus 11 squared will equal 81. I'll want to square root each side. So when I do that, I'm left with x minus 11 equals the positive and negative version of 9. So then x minus 11 equals 9, x minus 11 equals negative 9. We add 11 to each side. So one answer will be x equals 20. Add 11 to each side. And the other answer is x equals 2. Number 14, start by adding 2 to each side. We'll have negative 3 times x plus 5 squared. That's going to equal 24. Well, I want to divide each side here by negative 3, where I'm left with x plus 5 squared equals negative 8. At this point, when I take the square root of each side, I can see that I have a negative inside of my radical. So for 14, there will be no solutions.